So it's hot again. That's annoying. And I put away my other microphone and I'm using my webcam's microphone right now. And so you might hear, like, I think the noise cancellation isn't as good. So you might hear like a portable air conditioner going on in the background. So apologize, but I really want to record a video, especially since I'm in the middle of pretty much a deployment right now. So, um, yeah, where were we? Okay, so we were reading this chapter here. Excuse me. Okay, yeah. So we're working on this chapter. I know I had actually went through a few pages and then yeah realized that I was being recorded in terms of my audio. So I was just kind of moving my mouth on video and yeah. So just again, just try to catch up. I'm in this page here. I'm not sure which page it really is. 358. All right. An archive contains .o files. Have you ever used a zip or a tar file? Then you know how easy it is to create a file that contains other files. That's exactly what a .a archive file is. A file containing other files. So open up a terminal or a command prompt and change into one of the library directories. These are the directories like /user/lib or /min/gw/lib. So this one is the Windows version, and this one is a Linux or a Mac OS version. And it'll contain some library code. So it's already code that's already been compiled and packaged up for you to include. In the library directory, you'll find a whole bunch of .a archives, and there's a command called nm that you can use to look inside them. Okay, so basically, if you had a directory that contained a bunch of these, because .a files, you can look exactly what's in there by doing nm, and it'll list literally all the individual files in here. So these two files here exist inside the libl.a archive. So as a single file, you have these two files inside, kind of like a zip file. And nm will actually let you see what's exactly in there, and notice that they're just the same uh, object files that have been compiled using GCC, for example. Um, so yeah, and you'll distribute the headers separately so that you'll know exactly, at least your code, when they're including these files, know which functions that exist, like the signatures. Because with .o at this point, it's all kind of like binary, and you'll need the corresponding header files to at least be able to use this in your program. The header files and the object files kind of correspond with each other. So yeah. So the nm command lists the names that are stored inside the archive. The libl.a archive shown here contains two object files, libmain.o and libyywrap.o. What these two object files are used for doesn't really matter. The point is that you can take a whole set of object files and turn them into a single archive file that you can use with GCC. Before you see how to compile programs using .a, let's see how to store our encrypt.o and checksum.o files into an archive. So just for context, we wanted to combine our encrypt files and our checksum files into a single library file that we could use in other programs. And we wanted to create this like security library, which will have the encrypt and the checksum object files. And those encrypt and checksum object files are compiled from the encrypt.c, encrypt.h, and checksum.c, checksum.h files. And yeah, so we're going to be able to create an archive with these .o files. So the archive command, AR, will store a set of object files in an archive file. So here's the command to do that, AR-RCS, and then all this here. So this is going to be the file that you want to create, .a, and then this is going to be the list of files you want included into that .a file. So R means the file will be updated if it already exists. C means that the archive will be created without any feedback. So it's like silently creating, no logging, I guess. And then what's S? S tells AR to create an index at the start of the .a file. Okay, some tracking information. Yeah. Did you notice that all the .a files like lib have names like lib something.a? That's a standard way of naming archives. The names begin with lib because they are static libraries. You'll see what this means later on. So one thing we have to remember is we need to make sure we always name our archives lib something.a. If you don't name them this way, your compiler will have problems tracking them down. So it's just best to always prefix your library names with lib. So then we then store the .a in a library directory. So once we have this built and like packaged up, we're going to store this in our user USR slash lib, or like this USR slash local lib directory, which is basically the directory in which all other non-system libraries are stored, as mentioned in previous pages. So yeah, once you have an archive, you can store it in a library directory. Which library directory should you store it in? Well, it's up to you. You have a couple of choices. You can put your .a file in a standard directory like /usr/local/lib. Some coders like to install archives into a standard directory once they are sure it's working. On Linux, on Mac, and in Cygwin, the USR local lib directory is a good choice because that's the directory set aside for your own local custom libraries. So that's like the standard directory that we stick things in. Okay? Or we could put the .a file in some other directory. If you are still developing your code, or you don't feel comfortable installing your code in a system directory, you can always create your own library directory. For example, /mylib. Okay, but there's caveats to that. I think when you do that, when you compile, you have to put that full path into to tell the compiler that it needs to look for libraries not only in /usr/lib or /usr/local/lib, but also this custom directory too. With I think it's the .-i switch. Yeah. So finally, compile your other programs. The whole point of creating a library archive was so you could use it with other programs. Okay. If you've installed your archive in a standard directory, you can compile your code using the -l switch. Okay, so it's -l. Remember to list your source files before your dash. Okay, so -l comes after your code that you want to compile. Okay, HS security tells the compiler look for an archive called lib HS security. So the compiler is making assumptions that your library starts with lib already, and that's the reason why we should always prefix our library with lib, and it always assumes that it's going to be a .a. So yeah, we're using multiple of these libraries. So we're going to have -l, library 1, -l library 2, -l library 3. And then, yeah, so the -i here is optional. -i is needed if you're including a library that is not within the standard /usr/local/lib directory. So, whew, okay. And here, this would be the switch, I think. Yeah, why is it -l? Okay. Oh, this is the custom headers, and this is the library. Okay, I said it wrong. Okay, interesting. Let's read it. Can you see now why it's so important to name your archive lib something .a? The name that follows the -l option needs to match part of the archive name. So if your archive is called libawesome.a, you can compile your program with the -lawesome switch. But what if you put your archive somewhere else, like /mylib? In that case, you will need to use the -L option to say which directories to search. So it's -L, okay, -L is the custom directory. So if you have a library that's not in the /usr /local /lib or the /usr /lib, then you'll need to specify exactly the directory to search for. And I think if if it's just my lib like this, it'll search probably for the current directory that you're in, or at least where your code is in. Okay. Um, okay, so geekbits. Okay, so the contents of the library directories can be very different from one machine to another. Why is that? It's because different operating systems have different services available. Each of the .a files is a separate library. They'll There will be libraries for connecting to your network or creating GUI applications. Try running the nm command on a few of the .a files. A lot of the names listed in each module will match compile functions that you can use. Okay. Okay. So it just depends on the OS. All right. The T means text, which means this is a function. And then the name of the function is like underscore yyWrap, so it's yyWrap. So we prefix, in this case, an object file, I guess, yeah, they're underscore and then function name. What do U means? Huh, okay. The nm command will tell you the name of each .o object file and then list the names that are available within the object file. If you see a T next to a name, that means that it's the name of a function within the object file. Okay. Okay, cool. So the security guy is having trouble compiling one of the bank programs against the new security library. He has the source code as well as the encrypt and checksum source code in the same directory. For now, he wants to create the libhfsecurity.a archive in the same directory and then use it to compile his old program. Can you help fix this makefile? Yes, let's do it. Okay, so let's take a screenshot here and let's just start writing. Restore. Okay. No idea why. Okay, so let's take a screenshot. I think we just screenshot like this. And note the bank alt programs uses these input statements. Sure. Let's do this. Okay, that looks okay. Ah, there we go. Ah, wow. This is not very. It's like when I don't have things set up correctly, it's just so much harder. Okay. All right, let's do it. So let's just, you know what? Let's just maximize this right here. I think you can see that, right? Yes. Okay. I'm just looking at my screen. All right. So, okay. So this is the makefile encrypt o encrypts.c. So what do we do here? So we want to compile this thing to encrypt.o. So do we also need, let's see, right here, GCC-C, I'm guessing. That means to compile something to an object file. I think same thing here, -C, so these two are gone. And then libhfsecurity.a is encrypt.o and also checksum.o. Okay. And then we want to archive, we want to execute this archive. So this is a makefile script. You can do more than just GCC here. So AR-RCS, we want this file here, I guess, this libhfsecurity. So we want to create an archive, libhfsecurity. encrypt.a. We'll have encrypt.o, but we'll also have checksum.o. There. Then we'll have bank vault. Bank vault.c is also, we need to include what else? We have encrypt.h and checksum.h. Interesting. What else do we need? Well, I know what -l is. That's the library file. That would be the libhf security, I believe. This is going to get hard. But so that's a custom directory, and then -o is the bank vault, so that's output file. But we need for sure bank vault.c here. And then now that -i is the custom headers. So we can put one of these in here, but I'm not sure. -l will be the library. We're needing libhf security, I'm guessing, because that's the requirements for this line. So that, and then maybe this one here is the -lhf security. Okay, and then the include, since they're angle brackets like this, they must be in this USR lib. Yeah, it must be in USR lib or USR local lib. That's the second. Like, if we can't find it in the standard system directory, it'll also. Oh no, this is lib. I meant include. Okay, so it has to be include. So these are include files. So that's where the custom headers are at. Okay, include, and then -l would be the path of custom libraries. I'm guessing it's gonna be USR local lib. Let's see, USR local lib. Okay, let's try it. That's my answer. -e-c checksum o, libhfsecurity.a checksum.o, libsecurity.a, bankvault.c, and then the USR local include. And then this one will be the library path will be USR local lib, and then this will have the -lhf security. Compile all this into the bank vault. Hopefully I got some of this right. Okay, so let's move this here. Okay, so -e-c checksum o, libhfsecurity.a checksum o, cool. libhfsecurity.a here, great. Oh wow, okay. So bankvault.c, that's what this dot meant. Okay, so this is the current, it's telling to get the current directory. Oh my gosh. So we never needed this. This was just current directory. And then the -lhf security. Okay. Yeah, I had assumed that they were probably going to move all this stuff to the USR local include and USR local lib directory. So, again, assumptions. Okay, so bullet points. Headers in angle brackets are read from the standard directories. Examples of standard header directories, right? So these are what the header directories mean, are USR include or cmingw include. So headers, these are for the headers, so the .h files, okay? And the library archive contains several object files. You can create an archive with AR, and a common set of switches is -rcs, the name of your archive file, .a, and then all the object files to go along with it. Library archive name should begin with lib and end with a .a, and if you need to link to an archive called libfred.a, you can just use -lfred. And the capital L flag should appear after the source files in the GCC command. Okay, got it. There are no dumb questions. How do I know what the standard library directories are on my machine? You need to check the documentation for your compiler. On most Unix-style machines, The library directories include /user/lib and /user/local/lib. So it could be different depending on your compiler. I think in GCC it's fine. It's going to be the same thing. When I try to put a library archive into my /user/lib directory, it won't let me. Why is that? Almost certainly security. Many operating systems will prevent you from writing files to the standard directories in case you accidentally break one of the existing libraries. Is the AR format the same on all systems? No, different platforms can have slightly different archive formats, and the object code the archive contains will be completely different for different operating systems. Okay, that's the one thing that they mentioned earlier. If I've created a library archive, can I see what's inside? I thought the NM was also okay. Yes, AR-T file name will list the contents of the archive. But we could also use NM. That's what you just said, right? Interesting. Are the object files in the archive linked together like an executable? No. The object files are stored in the archive as distinct files. So they have nothing to do with each other. They're just a bunch of files just like clobbered together with no relation with one another. It's just for your program to access. Okay? So can I put any kind of file in a library archive? No. The AR command will check the file type before including it. So only .o files. Can I extract a single object file from an archive? Yes. You can extract the encrypt.o file from the libhfsecurity.a. Use AR-X. So maybe this stands for extract. libhfsecurity.a and the file you want to grab. Pretty cool. Why is it called static linking? Because it can't change once it's been done. When two files are linked together statically, it's like mixing coffee and milk. You can't separate them afterward. Should I use the HF security library to secure data in my bank? It's probably not a good idea. Like I said, it's just XORing, adding stuff. Okay, the linker exposed. This week's interview. So what exactly do you do? Headfirst says, Linker, thank you so much for making time for us today. It's a pleasure. I'd like to begin by asking you if you feel overlooked by developers. Perhaps they don't understand exactly what is it that you do. Linker, I'm a very quiet person. A lot of people don't talk to me directly with the LD command. LD? Yes, see? That's me. Oh, that's a lot of options on my screen. Let's see. Let's see what LD is. LD. Huh? Huh? LD. Oh. LD. Oh. Oh, there we go. Whoa, that is a lot. Oh, wow. You could do a lot with this. Okay. Exactly. I have a lot of options, a lot of ways of joining programs together. That's why some people just use the GCC command. So the compiler can link files together. The compiler works out what needs to be done to join some files together and then calls me. And I do it quietly. You'd never know I was there. I do have another question. Yes? I hate to sound foolish, but what is it exactly that you do? That's not a foolish question. I stitch pieces of compiled code together a bit like a telephone operator. I don't follow. The old telephone operators would patch calls from one location to another so the two parties could talk. An object file is like that. How so? An object file might need to call a function that's stored in some other file. I link together the point in one file where that function call is made to the point in another file where the function lives. So that's the job of a linker. Take the object files and your source file and figure out how to connect them together. You must have a lot of patience. I like that kind of thing. I make lace in my spare time. That's random. Really? No. Linker, thank you. Huh. Cool. Alright, so the Headfirst Gym is going global. The guys at the Headfirst Gym are going to spread their business worldwide. They are opening up outlets on 4 continents, and each one will contain their trademark blood, sweat, and gears gym equipment. The trademark software for their ellipticals. Wait. So they're writing software for their ellipticals, treadmills, and exercise bikes. The software will read data from the sensors that are fitted on each device and then display information on a small LCD screen that will tell users what distance they've covered and how many calories they've burned. Okay, it's like embedded software. That's the plan anyway, but the guys need a little help. Let's look into the code in a little bit more detail. So, counting calories. Alright, it's time to code. I do have a few minutes. This one might have to be short, but it's okay. HF Cal. Okay, the HF Cal library. I see that already. So the team is still working on the software, but they've got one of the key modules ready. The HF Cal library will generate the main data for the LCD display. If the code is told the user's weight, the virtual distance she's traveled on the machine, and then a special coefficient, it will generate the basic LCD details of the standard output. Okay. What do I call this thing? HFCal.c. That's what it says right here. The code will go into this file called HFCal. So all this. Okay. Include stdio.h. Include hfcal.h. Okay, so angle brackets means that it's going to be, we have to specify either we put hfcal library in /user/local/lib, or sorry, the includes /usr/local/include, or we specify the custom directory when we compile with the -i, capital I. So, okay, and then already it's complaining. You see that? Include path. Okay, so it doesn't recognize until we specify. So display calories, float weight, float distance, float coefficient. Okay, now we're going to say printf weight percent 3.2 f pounds. Okay, so printf distance, so that's the virtual distance traveled, percent 3.2 f miles. That'll be distance. And then printf calories burned. Again, percent 4.2 f cal coefficient times weight times distance. Okay, and that's all there is to it. The team hasn't written the main code for each of the equipment. When they do, there will be separate programs for the ellipticals, treadmills, and exercise bikes. Until then, they've created a test program that will call the hfcal.c code with some example data. So this will be elliptical.c. This is like a test file. So it's a simple main function that passes in these argument values. 115 pounds, 11.3 miles, I guess. Yeah, it is. And then coefficient 0.79. I don't know how they judge that. Oops. Getting messages. Okay. Alright, so pound include stdio.h, pound include hfcal.h. So the same hfcal. So this will be the library. It may display calories 115.2, 11.3, 0.79, return 0. Cool. So yeah, again, red. Okay. It's supposed to look like this, but I don't think we can compile yet. So now that you've seen the source code for the test program and the hfcal library, it's time to build the code. Let's see how well you remember the commands. Oh wait, were we supposed to create the hfcal.h? Oh, it just contains the declaration of the display calories function. Okay, let's just do that. Let's just do this. HFcal.h, and then we'll just say it is, what was it, the display calories? A float, a float, float, and then a float. Okay, so void display calories, we'll take in float, float, float. We don't have to specify the names of the parameters when we do declarations like this, so that's okay. Now everything is green, and we need to compile. So, start by creating an object file called hfcal.o. The hfcal.h file is going to be stored in the /includes. Okay, so we're going to have to make a subdirectory called includes, and we're going to have to move the hfcal here. Okay, and this should be red again. Yeah, this should be red again because, well, maybe, okay, it was able to find it. That's interesting. Shouldn't have. I'm surprised. Alright, so now we're going to have to compile. So let's do it. Create an object file. So gcc-c, and then we're going to do -i. Is it -i equal? In this case, let's go back up here. -i. Okay, so -i space. Okay, -i space include, and then the file here is going to be hfcal.c, and then elliptical.c, and then we want to, oh, we can just compile hfcal.c. Ooh, I'm kind of struggling. Hfcal.o. Oh, I'm not even in the right directory at all. cd code, average dev. I'm losing it. I'm tired. cd projects, cdc, cd hfcal. Okay, let's try that again. Okay, lsla. So I do have hfcal.o. Next, you need to create an object file called elliptical.o from the ellipticals.c test program. Okay, that's easier, I think, now that I know this. -c elliptical.c, but it also needs a hfcal .h too. So I had to specify the custom includes, and then output that to elliptical.o, and if I lsla, I should have it here too. Okay, so far so good. And then now you need to create an archive library from hfcal.o and store it into /libs. So I'm going to make dir libs first because that's going to be /libs. Okay, so now it's going to be, I think, AR, and is it -rcs or something like that. Let's see. Where is it? AR.rcs. Okay, and then we're going to say lib hfcal. Lib hfcal. .a, and then the hfcal.o is the one that will go in there. Okay, let's see what happens. lsla. Okay, it's in there. Then we're gonna move lib hfcal.a to libs. So lslibs, okay, in there. Finally, create the elliptical executable using the elliptical.o and hfcal archive. Okay, so it's going to be GCC. And then we're going to say, so we need elliptical, and we need to use the elliptical.o executable. Ooh. So is it going to be -L, and then we're going to say hfcal like this. I know that one for sure. And then -O elliptical. I know that one for sure. And I don't know how to link like this. This is tricky. I've already done so much. I guess we can just. I guess we could just say elliptical dot O. Let's see. Oh, we had to specify custom library directory too. So dash L libs. Okay, that seemed to work. Dash L libs. Okay, LSLA. So we have elliptical. That works. So GCC elliptical dot O dash L dot slash libs. Then lowercase dash L HF cal. And then dash O elliptical. Let's see what happens. I don't know if it's gonna work. And it worked. Okay. That's good. Didn't really need to look at answers. All right. So this is similar. Okay, was it similar? Let's see. GCC-C HFcal.C. Okay, fine. I did it afterwards, but similar. Similar. Oh, right here. Wait, all the way up here. Yeah, similar. Okay. Then we had the RCS, libs, HFcal.A, which, oh, I think we could have just specified the output directly instead of doing the move command. And then our compile was okay too. Okay, this looks good. And this is a nice trick. I didn't know this, that you can just pass in the .o directly to GCC. Okay, I'm getting pinged for stuff, so I'm going to have to stop. Thanks. I'm gonna check this in. Okay. Uh-oh. Oh, yeah. Okay, so my computer messed up, and I had to do weird stuff to it, and I don't think I'm on the internet. Dang it. Okay, let's see. Can I go to Wi-Fi? Yeah. Okay. Great. Cool. Yeah. Just hopefully talk to you guys tomorrow. Thank you.